Okay, so I did problem 68 in section 8.4, which reads, find the area of the shaded region of the circle of radius A if the chord is h units from the center of the circle. See figure. So this is my figure, and I only really regarded the top semicircle because it's easier that way, and it's unnecessary to regard the bottom because that doesn't impact the area. So I set up my equation, which would be y equals a squared minus x squared, and I subtracted the higher integral by the lower integral, which would be integral of square root of a squared minus x squared dx minus the integral of h dx, where the integral of h dx is just this region. So I looked at the square root of a squared minus x squared and realized that was the triangle, the trig substitution. So I made my trig substitution over here. In the lower angle, the adjacent side would be square root of a squared minus x squared. The hypotenuse would be a, and the opposite leg would be x. And because it's the opposite leg, you can determine it's to be the a sine theta. And then I found dx to be a cosine theta d theta. And then for this square root of a squared minus x squared, which is what I want to get to, I subbed in my x, a sine theta. So I got a times the square root of 1 minus sine squared theta. And using the trig identity of the Pythagorean identity, it becomes a cosine of theta. And then, so I plugged that back into the a cosine theta, into my square root of a squared minus x squared. And I factor out the a squared because it's a constant. And I also found, I took my dx and I plugged that in. So that left me with a squared integral of cosine squared theta d theta minus hx, because h is a constant, therefore it's hx. So in order to find the actual chord, I took the power reduction formula to reduce cosine squared of theta into 1 plus cosine of 2 theta over 2 d theta. And then I separated the numerator, so the integral of 1/2 d theta plus the integral of cosine 2 theta over 2 d theta. So the integral of 1/2 d theta becomes 1/2 theta, whereas the integral of cosine of 2 theta over 2 becomes 1/4 sine of 2 theta. And so I solve for theta to be arc sine of x over a, because x equals a sine theta. You manipulate that and you're left with theta equals arc sine of x over a. So I plug that back in, so 1/2 arc sine of x over a. And I use the sine of 2 theta identity to reduce sine of 2 theta into sine theta cosine theta. 2 sine theta cosine theta. And then I factor out my 1/2. And I'm left with arc sine x over a plus sine theta cosine theta. And then I return back to my trig triangle to find what sine theta and cosine theta would be. Sine theta would be x over a, cosine theta would be the square root of a squared minus x squared over a, because it's opposite over hypotenuse and adjacent over hypotenuse, respectively. And then because I noticed the a squared will cancel out with the denominator a's. So then I'm left with the 1/2 arc sine of x over a plus x square root of a squared minus x squared. I've factored in my 1/2 into the parentheses. So 1/2 arc sine x over a plus 1/2 x times the square root of a squared minus x squared minus hx plus c would be my final answer for the area of the shaded region of the circle.